So today, let's focus on reduction formulae 2. So we are doing today cofunctions. So in our previous lesson, we talked about the quadrants. Okay, so let me draw my Cartesian plane here. That has 4 quadrants. So in our previous lesson, we said that the first quadrant is 90 degrees minus theta. Okay, so it's, let me write 90 degrees here, then 0 degrees there, then 360 degrees, 270, then 180 degrees. So I'm saying now, we said that the first quadrant is 90 degrees. It's 90 degrees minus theta. Then here it's 180 degrees minus theta. Then again it's 90 degrees plus theta. Then here it's 180 degrees minus theta. Then here it's 360 degrees. Sorry for the reaction that is happening here. So 360 degrees minus theta. So we said that, let me write that again. We said it's reduction formulae 2. Then we are dealing with what? With cofunctions. Okay, so I said that 90 degrees here. So I said that in the first quadrant we have 90 degrees minus theta. Then in the second quadrant we have 180 degrees minus theta and 90 degrees plus theta. Then in the third quadrant we have 180 degrees plus theta. Then in the fourth quadrant we have what? We have 360 degrees minus theta and also negative theta. That's what we said. But now we're gonna focus on cofunctions. So let's erase other ones. Then we're gonna focus on cofunctions. So what are the cofunctions? Cofunctions are these ones that have 90 degrees. So we're gonna focus on these cofunctions. Okay, now let's remove the other angles here. So now if you can see, let's remove this and we're gonna rewrite it. So if you can see now, we have in the first quadrant we have 90 degrees minus theta. Then in the second quadrant we have 90 degrees plus theta. So these cofunctions, they only work in cosine and sine. They only work in cosine and sine. They only work in cosine theta and sine theta. It depends your angle. It can be sine beta, it can be sine alpha. But those angles there, 90 degrees plus theta and 90 degrees minus theta, they are possible on cosine and sine. Tangent can never be a cofunction. So these are the cofunctions. They work together. We say they are equal when they are having those angles. But we're going to see how are they equal. So we're going to see that, okay, they're equal in this form. So now I want us to know that cosine theta is positive here, then sine theta is positive here. So these are the things that we must know here. Cosine is positive and the sine is positive. Then when we come to this one, only sine that is positive, sine theta that is positive, but cosine is what? Cosine theta is negative. So this is what we're going to have here. So that's what you must know. So now let's start with the first quadrant. So I'm going to write here. I want you to sit there on the first quadrant while I'm writing. So we're going to start with 90 degrees. Don't mind on this fourth quadrant. I'm not specific writing based on fourth quadrant. I'm just writing on the space that I have here. So never think that I'm referring to the fourth quadrant. I'm just writing on the space that I have. So now let's start with 90 degrees minus theta. So if now I have sine open brackets 90 degrees minus theta. So how are you going to write this? You're gonna say, which quadrant is this? It's first quadrant. How is sine in the first quadrant? Is positive. So what is the cofunction of cosine? So of sine, it's cosine theta. This is what you're gonna write here. So it's positive cosine theta. Next time, don't write positive like the sign, but know that it's positive when it's invisible sign, when there's an invisible sign there. So the cofunction of sine, it's cosine theta. It's equal to that. Then now, let's come to cosine theta. If now, okay, number one, number two, if now I have cosine, then 90 degrees minus theta, then what will I have here? Okay, now I'm going to ask myself, 90 degrees minus theta, which quadrant is this? So it's the first quadrant. How is cosine in the first quadrant? So it's positive. Then what is the cofunction now? Coming to this. What is the cofunction of cosine? Cofunction of cosine is sine theta. So now this is your answer. That means cosine open brackets 90 degrees minus theta is equal to sine theta. And also sine open brackets 90 degrees minus theta is equal to cosine theta. This is what you should know. These are called cofunctions. So now let's go and prove this. How to prove it? So let's start with the sine 90 degrees minus theta. So now let's say if I have here, okay, let's prove this. If now I have sine 10 degrees, then this is gonna be equal to sine open brackets 90 degrees minus, what number can we subtract from 90 degrees to get sine 10? So you're gonna subtract by 80 degrees. So this is gonna be 90 degrees minus 80, we're gonna have 10 degrees. Okay, so it means now, therefore, your sine 10 degrees is equal to okay, since now we said the 90 degrees minus an angle is the first quadrant, and sine is positive in the first quadrant, so its cofunction is cosine, right? So what is the angle there? It's gonna be 80 degrees. That's what you're gonna write. If you can check in your calculator, sine 10 degrees is the same number in the calculator when you press cosine 80 degrees. So hence why now these are set cofunctions. So now let's see on the calculator what number are we gonna get. So if I press in the calculator sine 10 degrees, then I'm gonna get 0.1736 and so on. Then again here, if I press cosine 80 degrees, then I will get the same answer, 0.1736 and so on. You see, so this means that it comes here now that when you expand this, or when this is reduced, we're gonna have 90 degrees minus an angle. So our angle now has to be equal, whatever we're gonna subtract in the bracket has to be equal to that angle there at the subject of the formula. So this is the same as this, because when you say 90 degrees minus 80 degrees, we're gonna have 10. So that's why we expanded using the brackets there. So we got 80 degrees. We got our cofunction as 90 degrees minus an angle. As you can see there, 90 degrees minus theta. So we had cosine theta. Now we had cosine 80 because we take that angle as it is here. So that's what you must know. And also we can prove the one for cosine. So if we can have here cosine, okay, number one, number two. So if we can have cosine 80 degrees, then is equal to, then now what you're gonna write here, what is the cofunction of no, let's not start with the cofunction, but let's start with expanding what is on the left hand side. So if we can expand this, we're gonna say 90 degrees minus, what number can you separate from 90 to get 80? It's gonna be 10 degrees. Then 90 degrees minus 10 degrees. So whenever now you have 90 degrees minus an angle, remember we said 90 degrees minus theta is a cofunction. So 90 degrees minus an angle, that theta is standing for the angle, whatever number that you put on that theta. So now you're going to have cosine 880 degrees. I don't know what's happening there. Okay, but then let's focus here on this one on number 2. So when you have cosine 80 degrees minus, when you have cosine 80 degrees is equal to, so now what is this quadrant? So this is the first quadrant. That means cosine is positive in the first quadrant. So that means you're gonna write your positive there, which is invisible. Then what is the cofunction now of cosine? So cofunction of cosine is sine 10 degrees. You see? So these are equal. So if we can go to the calculator, then we check cosine, it's cosine 80 degrees. You're gonna have 0.1736 and so on. Then if you now go to the sine 10 degrees, then you're gonna have the same 0.1736. Can you see that these are equal? Because not these are equal because they are cofunctions. Cosine 80 degrees and sine 10 degrees, they are the same thing. But for you to see, you must expand first, okay? So you must expand. One thing I can tell you, cofunctions only work on acute angles, angles that are less than 90 degrees. Eh? So that's where you're gonna use the cofunction. So I'm saying cofunctions only work at angles that only work at angles that or only work at acute angles, or on acute angles, whatever. So only work at acute angles or on acute angles, or let's put on the so if you have sine 40 degrees, that means you need to expand it. You're gonna say sine, open brackets, 90 degrees minus, what number are you going to separate from 90 to get 40? It's 50 degrees. Then you're gonna write sine 40 degrees is equal to, then what is this quadrant? 90 degrees minus an angle is the first quadrant. So how is sine in the first quadrant? Is positive. So what is the cofunction of sine? Is cosine. Then you're gonna write cosine 50 degrees. These are equal if you can check them in the calculator. If you can say now sine 40 degrees is gonna be equal to 0.6427 or 428. Then you come now to cosine. If you can check cosine 50, click on cosine 50. It's going to be the same number, 0.6427, and so on. So these are the same numbers. These are the same. We call them cofunctions. So they are equal. Okay. Remember, they only work in what? In acute angles. This is the whenever you get the acute angle, guys, please, whenever you get the acute angle, use the cofunction. If you didn't use the cofunction in the what? In the acute angle, you're not gonna get something correct. Okay? Always, if you want to change, maybe you want to divide things that look alike in the division, maybe you want to cancel. Then you see that, okay, I can't cancel that because these angles are not the same. Check if it's an acute angle, then you do the cofunction method. Okay, so that everything can be equal, then you divide and you cancel so that you can have one answer. Okay, so now let's have examples of these cofunctions. So we started with let's not have examples yet. Let's finish them. So we were dealing with the cosine 90 degrees minus we're dealing with the 90 degrees minus theta. Ne? Then now we are done with 90 degrees minus theta. Let's go to what? To 90 degrees plus theta, which is what? The second quadrant. Okay? We are done with 90 degrees minus theta. We saw that the functions are all positive in the first quadrant. Now it's going to change. The second quadrant is going to have positive sine theta. Then the second, it's going to have again the negative cosine theta. Okay, so now let's go and have 90 degrees plus theta. It's going to change now, guys. It's going to be the same method, but it's going to change on cosine, because cosine is negative. That's where it's going to change. So if we can now start with, so sine theta, okay, let's write like this. Okay, sine theta is gonna be equal to cosine, okay, how did I put it there in the first? Oh, I used the quadrants. So guys, here 90 degrees plus theta. So what is so you're gonna ask yourself, 90 degrees plus theta. What is this quadrant? So it's the second quadrant. Okay. How is the okay, let's do this way. Let me not write. Let's do the same way, the way we did here, so that you can see. So our equal sign has to be here. Then what is the, okay, if we say 90 degrees plus theta, then we know that, okay, this is the what? This is the second quadrant. Okay. If we say is the second quadrant, how is the sign in the second quadrant? So sign in the second quadrant is positive. That means it's what? It's positive. What is the what is the cofunction of sine? So cofunction of sine is gonna be cosine angle there, which is that angle is theta at this moment. So this is your answer. Number 2, coming now to cosine, then 90 degrees plus theta. Then how is cosine in the second quadrant? Because 90 degrees plus theta is at the second quadrant. So how is cosine in the second quadrant? It's gonna be negative. Then what is the cofunction of sine, of cosine? Because now 90 degrees plus theta is a cofunction, means cofunction. Then it's your sine there. So it's your sine theta, sine that angle. If you had a number there, you're going to put this number here. But now we are presenting like as in symbol. We're gonna write sine theta. So this is what happens, guys. So let's prove this now, if it's correct or not. We're gonna prove it if we get the same numbers, both sides. So number 1, we said that if we have now, if we can prove this way, it's still gonna be the same thing, guys. If we say 90 degrees, maybe if we get, okay, let's make an examples of the same, but now we're gonna add. So if I have here sine 10 degrees, then when I expand this, I make it equal to, I apply the cofunction. What number am I going to, okay, what should I write now if I have 90 degrees? Okay, sine 10, then what number am I going to get? No, let me not write with the 90 degrees, because I'm not gonna get the same. So I will need to have another angle, which is sine 100. Yeah, guys, you must be wise in this, ne? Must be very wise. But I said to you, it's you only apply when it's acute, but it can be applicable here as well, because okay, so you're gonna have sine, then 90 degrees. So if we expand this, 90 degrees plus 10, né? It's gonna be the same thing as this. So now sine 100 degrees, guys, this is what I just created. I am not sure if it's gonna apply on this, but then we need to get some example of what we gonna write. Otherwise, I said to you, this only apply in the cofunction, in the acute angles. But then let's work on it in this case. So now, how is cosine in the first, in the fourth, in the second quadrant is positive? Then what is the cofunction? It's cosine 10 degrees. Then number 2, when we have cosine 100 degrees, then your answer there will be, when we convert it into its cofunction. So let me just check here if we can get the same number. Sine 100, then cosine 10. Sine 100 and cosine 10. Yes, guys, we're gonna get the same number. So here it's cosine 90 degrees plus 10 degrees. Then cosine 100 degrees. Then here it's sine 10 degrees. Can you see? Because now on negative, not positive. So you ask yourself, how is this quadrant is the second quadrant? How is cosine in the second quadrant? It's negative. You put the sign there. Then you say, now what is the cofunction of cosine? It's sine. Then what is the angle there? It's 10 degrees. Then you have negative sine 10 degrees. Okay? So that's what you're going to have. So these are the examples. These are the proofs, guys. Otherwise, now let's go and focus on the example questions. So now let's go to practice problems. Let's go to practice problems and see how do we apply these. So these are only applicable when we are dealing with the simplification of reduction formulae. So they will help you to move to another step when you want to convert something. So now let's have okay, the question will say number 1. The question will say simplify the following. The following as far as possible. So you will need to simplify this. So A, then your A, it's cosine, then open brackets 90 degrees plus theta, then sine 360 degrees. What's happening now? Okay, so practice problems. Let's write again here. Practice problems. Simplify the following as far as possible. So now you have your sine 360 degrees minus theta here. So what will be the answer here? Because this and this can cancel, you need to make them the same. So you change this to be a cofunction. What is that? What is this quadrant? Is the second quadrant. How is sine in the second quadrant? Cosine in the second quadrant is negative. Then what is the cofunction of cosine? Is sine. Then you write that angle there, which is theta. Then now sine 360 degrees minus theta. What is this quadrant? It's fourth quadrant. How is sine in the second quadrant? It's in the fourth quadrant, it's negative. So it's sine theta there. So when you divide this with this, you're going to have -1 and -1. Then now it's going to be +1. So they will cancel and leave 1. That's what you usually say, guys. The numbers, you will say the numbers are cancelling. The numbers are not cancelling, they divide each other. So let's have our B. So now let's say we have sine, then open brackets 360 degrees minus theta, open close brackets, multiply by sine 90 degrees plus theta, close brackets. Then that's your division line. Then cosine 90 degrees minus theta, close brackets, multiply by cosine 360 degrees minus theta is equal to, okay, so now what are we going to do now? We're going to write these according to their signs in the quadrant. So this is a fourth quadrant, that means we have negative sine theta. Then close brackets, open, always use brackets when you're dealing with the sign. Then 90 degrees plus theta. What is the cofunction of this? It's sine. So how is sine in the second quadrant? It's cosine. So cosine will be positive here. Then now what is the cofunction of this? It's sine. Then how is sine in the first quadrant? It's positive. Then there, how is cosine in the fourth quadrant? It's gonna be positive cosine theta. Then this will cancel with this and leave negative 1 and leave positive 1 there. This will cancel with this and leave 1 and positive 1. Negative 1 multiplied by 1, it's gonna be negative 1. Then positive 1 multiplied by 1, it's gonna be 1. Then negative 1 divided by 1 is gonna be negative 1. So that's your answer there. You simplified it fully as much as you can. So the question now says, show that sine 270 degrees minus beta, close brackets, is equal to negative cosine is equal to negative cosine beta. So I want you to know which angle is this. So if we can break it down now, 270 degrees is in third quadrant. So that means to go to 270, you say 180 degrees plus 90 degrees to go there. Ne? That means this is the angle alone that we can break down. Ne? So what we're gonna do now, we're gonna say, therefore, sine, we're gonna write a square bracket, then small bracket here. No, not yet. We haven't expanded. We are just writing the question now. So we are still showing that 270 degrees is equal to 270 degrees minus beta is equal to negative cosine beta. So here, what we need to do here is to form a cofunction to convert sine into cosine. But then we need to be very wise. So what are we going to do here is we're going to form a new angle now, that this angle here, which is 270 degrees minus beta minus is okay, let's put it this way. So we're gonna replace this 270 here, ne? Look at this. We're gonna replace this 270 by this because they are both equal. Remember in the Cartesian plane that we have to go to this 270, we go anti-clockwise. So we say 180 degrees plus an angle. That means to come here exactly, we're gonna go at 90 degrees. Hence why I said where is this? Okay, so we are here, not here. Okay, so I'm saying now we need to replace that this 270 ne, with 180 degrees plus 90 degrees. So this is what we're gonna do. We are replacing this 270 here, then minus beta, the one that was there already. Now if you can see, what we're gonna do is forming angles, eh? So what does it mean now to you? It means, let's remove the brackets. To remove the brackets, we're gonna say, we're gonna write 180 degrees, then positive multiply by negative, it's gonna be negative. Or else, let's put it like this. Let's not remove brackets. Let's just write, because now it's not allowed to say positive multiply by negative. It's not allowed, so we're gonna write them as they are. So that's how they are. But now we need to be very wise and form something that we know. Okay? Then what we're gonna do, we're gonna separate this as 180 plus theta. Ne? So we need to take these two and make them one angle. So it's gonna be 180 degrees plus an angle. So these plus theta. So these are these will be forming one angle. So it's gonna be 180 degrees plus this 90 degrees minus beta. So I just took them, both of them, so that we can have something that we know. Do you still remember when we say sine 180 degrees plus theta? So we change, we want to form this 90 degrees minus beta to be that theta, ne? So now we're gonna have something that we know. How is this quadrant? What is this quadrant? 180 degrees plus theta. It's third quadrant. That means sine is negative. So we're going to have sine and that angle. Now let's have this one again. Sine and that angle there. 90 degrees minus beta. Okay? So this is what we are having there. Then what we're going to have now is this is the cofunction. So if we can open the brackets for this negative. Okay, 90 degrees minus beta is in the first quadrant. So obviously it's a cofunction. So it's positive. So what it's gonna be positive then, because it's in the first quadrant. So what is the cofunction of sine? It's cosine. Then it's gonna be beta. That means now negative multiplied by positive, that is here, it's gonna be negative cosine beta. Therefore you proved that this which one, this is equal to this. Therefore now you can say, therefore this left hand side is equal to that right hand side. That's what you need to have there as your answer. So practice this method that I did here. Make sure that you understand it. If you don't understand it, screenshot it and ask me again to explain. Okay? The test is following.